See, what we states in availability that we should have our all devices, all the modules, power, power supply and supervisor, everything should be in a dual standard. So Nexus provides the very high availability feature in the network environment. How? Because if I talk about from hardware point of view, each Nexus has two supervisor, right? Two fan tray. It can be a system fan tray and it can be a fabric fan tray, right? We have a fabric module, right? We also put 5 in numbers, and we have a power supply. So power supply, we have read that the Nexus 9 and Nexus 7009 has 2 power supply, 10 has 3 power supply, and 18 has 4 power supply. So all are from the hardware point of view. If you see that they are highly redundant, right? So the Nexus was made in a from that mind that we should provide our system in a high redundant mode, high availability mode, so that even if one of your systems fails, then also your Nexus box and your data traffic should work properly. So let's move up upon the what are the other features. We will talk about the in Nexus high availability. We will talk about the ISSU, we'll talk about supervisor failover, we'll talk about a lot on this. So what is the method to do the ISSU, how we how the supervisor switchover is done, how the Nexus dual, if you have a two supervisor, how they communicate to each other, how they talk to each other, what type of packets, all these type of things we'll talk about today. So our first topic is the Cisco Nonstop Forwarding, NSF, right? What does this mean? This means that Cisco has a feature of non-stop forwarding. That means your data plane, right? What happens? Suppose you have see, this is your Nexus data plane, this is your kernel, this is your availability manager, and over this all your protocol is working, like OSPF, BGP, PIM, IPv6, STP, HSRP, LSCP, everything, right? So non-stop forwarding is also referred as a grateful restart, right? So what happens? Suppose you are working, your Nexus box is working properly, and some of the time your OSPF get restarted, right? Or OSPF your process faces some problem, right? Then what will happen? So there will be 3-4 steps. So your high availability manager, over which your OSPF is running, right, will restart the process. What it will do? It will restart the process. Second, obviously your Nexus box is connected to some of other box also. So a graceful restart message will be sent to its peers, right? And when it is done, the control flow information received from peer and installed in all the tables. And then suppose you are also running OSPF here, you are also running OSPF here, right? And at certain point of time your OSPF stops working or face some problem. What will happen? It will restart its OSPF process. It will send a graceful restart message that, boss, my OSPF is facing some problem. I'm going to restart it. Right, and once this restarted, again the neighborship is formed, and then routing updates will be shared, and then your actual data traffic will flow, right? So this is what we call as a non-stop forwarding, right? So this is the four steps we Nexus follows while provide the non-stop forwarding. So there are other methods also for regarding to this. Let me go through that. So the Cisco 9 Nexus 7K provides the Cisco non-stop forwarding extension for support of routing protocols. And it may have, there are lots of other situations occurs which the non-stop forwarding feature provides the support. One is stateless restart. What do you mean by stateless restart? In the stateless restart, if a switch experiences a cold reboot, right, the network stops forwarding traffic to the system and removes the system from the network topology. This is called, we say, as a cold reboot, right? In a cold reboot, what happens? The network stops forwarding traffic to the system, and the box, it will be removed from the system from the network topology. In this scenario, what happens? In this scenario, the process undergoes a stateless restart, right? What it will do, then what it will do, Nexus box will do, the Nexus box will go a stateless restart procedure. In the stateless restart procedure, it will remove all the neighbor adjacencies on the local system, all the routing adjacencies, whether you are using a EIGRP, OSPF, BGP, it will be its neighborship will be removed, right? The Nexus software applies the startup configuration. It will apply the startup configuration, and routing process rediscover, and the neighborship is established and the adjacencies is gained, right? So you understand what I mean to say here. Suppose your Nexus box is working. Now what happens? It faces a cold reboot. Cold reboot means there will be no traffic. There will be and the system will be removed from the network topology. Then what will happen? Then in this case, the Nexus box will follow a stateless restart procedure. In the stateless restart procedure, what will happen? First, it will remove all of its neighborship from the network, and then the Nexus OS software will apply the startup configuration, makes the box ready, and then the routing adjacency will discover, neighborship will form, routing table will be exchanged, and then your traffic will start flowing it. First thing. Second problem is what happens when your supervisor, there are two supervisor and one of your supervisor fails. Then what happens? If you have a supervisor suit 1 and suit 1 in slot 5 and slot 6, so by default slot 5 will be active and slot 6 supervisor will be in standby, right? So what happens if the active supervisor fails? What will happen? Then the supervisor switch over will happen, right? Now your standby supervisor, which is in slot 6, will become the active supervisor, right? Then what will happen? When the supervisor switchover happens, also here also it will go for a graceful restart by announcing that it will be unavailable for period of time. What will happen when your supervisor switchover is done? The Nexus box will announce to its peer that, boss, I am not be available for a certain period of time, right? During this switchover, the neighbor device continue to forward traffic and keep the system in the network topology. During the switchover, because your supervisor is there, right, it is only a taking switchover, but in that case also, in the line cards, your control plane will be there. The Nexus box will be providing forwarding the traffic and keep the system in the network topology, right? And after the supervisor switchover, the Nexus box comes into operation again, right? And it helps to achieve the adjacency, right? Now third point, what happens if the routing process failure happens, right? So there will be a procedure of graceful restart on routing process failure. When your routing process fails, what will happen? The Nexus box will automatically restart its routing process if it experiences any problem. After the start, the routing process initiates a graceful restart. Graceful restart means it will send a message to its peers that I am my process has been restart. I will and please wait for some time, and then it will form once the process will be restarted, and your OSPF or EIGRP or BGP process it start working properly, then it will form the neighborship, and then it form the adjacencies, routing table is exchanged, and then your traffic starts flowing. So these are the three method that a Nexus high availability manager follow. So in the case of cold reboot, this method is followed, stateless restart, right? Where your box will be removed from the system logically, not physically, and then the Nexus box will reapplied startup configuration, makes the box is ready, and then the adjacency is formed, and then your routing process starts. Now when a supervisor switchover happens, your high availability manager will follow this step. In that case, it will send a graceful restart message to its peers, and then and in this case the data traffic will be keep in forwarding. Once your graceful restart message will be sent, the neighborship will be received and formed, routing table will be populated, and then it will be started working. And in the third case, when a routing process failure happens, it again follow the graceful restart or routing process failure. So these three types of failures if happens, the high availability manager automatically takes these actions. Right? Understood? Well,
Okay.
dual supervisor system, how the Cisco non-stop forwarding and a stateful switchover happens, SSO happens, right? So suppose you have this is your Nexus box, right? And you have a two supervisor, one is active and one is standby. Then what happens in between them? Right? So what happens if your supervisor is active, then all its routing table, all the working is handled by active supervisor. So standby supervisor will send a message which is called as a request snapshot. The standby supervisor will tell to the active supervisor, boss, please give me the snapshot of your working. Right? This active supervisor will provide it to a snapshot to him. Now once the active supervisor provides snapshot to him, that means the active and standby supervisor will have a same state. Each will have a same configuration, each will have a same routing table, MAC address table, CEF table, everything will have. So the third state reaches is the state is synchronized. That means your active supervisor and the passive standby supervisor are in synchronized. Right? Now, once it is synchronized, then what happens? The active supervisor sends a message to the standby that start all your services in standby and notify. Means be ready, start your services, but in standby mode. You should not be act as active mode. If I fails, then your services are already started. You have to only take over. And then once it is done, if active supervisor found any event, then it sends a event driven sync message to the standby supervisor. Right? So suppose if it goes down, it will send an event message to standby that, boss, I am down, please take my control. And in this state, the standby supervisor has already been synchronized, and it has already started its services in standby mode. It will convert itself into the active mode, and all your control will be on the standby, on the active supervisor. Then the second one, right? So this is how the dual supervisor system works. I am repeating, in the dual supervisor system, what happens? The standby supervisor will request for a snapshot. Right, boss, give me a snapshot. The active supervisor will send the snapshot to the standby supervisor. Once the active supervisor and standby supervisor, they have the same configuration, control plane, data plane, routing table, MAC address table, everything. The state is reached, which is called as a synchronized. The state is synchronized. Then the active supervisor will ask the standby supervisor to start its services in standby mode, so that in case of failure, if the active supervisor get failed, so the standby supervisor will take its role and all its services are already started, so there will be no traffic disruption. And fifth, if any event driven message is received on the active supervisor or active supervisor founds that there is any event, all the event driven message, sync message will be sent to standby supervisor to make him aware that I am getting these event, please be aware of that. Correct?
Okay.
Yeah.
Okay.
Now, how this supervisor switchovers happens in the Nexus box. So see, there are two type of method over which the supervisor switchover happens, right? First thing is manual. Manual means if you are planning to remove your primary active supervisor, or you are doing some activity on the active supervisor, then you will do that is a manually switchover. Or automatically switchover, that means if your active supervisor got failed or if it face any problem, then the supervisor switchover will happen. So there are two methods of supervisor switchover. One is manual and another one is automatic. Right? Manual means you have manually done it, right? And automatic means it is triggered by failure of active supervisor. Right? In both cases, the stateful switchover will happen because control of traffic is not affected. Control plane traffic is not affected. Why? Because they already have synchronized their states. Right? While supervisor switchover, it also doesn't disrupt the data traffic because input output module are not affected. If in the Nexus box, what I said earlier, that each line card will have a copy of the control plane, right? So even though your supervisor is failover, your data plane is not getting affected. Why? Because all the copy of the routing table and all the MAC address table will be there in your FIB, forwarding information base. And the forwarding information base are kept in a line card where all the traffic, routing traffic or a switching traffic will not go to the supervisor. It will have their routing table and MAC address table locally stored in the FIB module, in the line card, and from there it checks and it forward the traffic. So this what happens when the supervisor switchover happens. In the supervisor switchover when happens, then there will be no control traffic loss, no data traffic loss. Control traffic is not lost because the both active and standby supervisor are synchronized with each other. They have already shared its states, and the data plane will be not affected. Why? Because the routing table and the MAC address table, which are created by the supervisor engine, the supervisor engine sends its copy locally to save it on the line card, and the line card have its own routing table and MAC address table locally stored, so there is no point of data traffic disruption. Right? So this is how I have elaborated that switchover occurs only one of the following two mechanisms. The active supervisor module fails and the standby supervisor module then automatically recovers. So it is automatic. You manually initiate a switchover from active supervisor module to standby supervisor module. So this is manual and this is automatic failover. So when a switchover process begins, another switchover process cannot be started on a same switch until the stable standby supervisor module is available, right? So suppose if you are doing some switchover, then another switchover will not be happening till the time it's working. If you want to read it, read it. right? So once you are doing switch over, so you have to see some of these things, keep in mind while switch over, otherwise your switch over will fail and your system will go down. So once while you are doing a preparation for supervisor switchover, what you will see that you go to the log into the Nexus box and see that your standby supervisor must be in HA standby mode. That means high available standby mode. So how you will see? You will go into the Nexus box, put the show module, and in the show module you see there is a supervisor module, and it will be seeing as a HA standby mode. It should be there in HA standby mode, right? Second thing, your standby supervisor module must be stable, right? Third, auto copy feature must be active, right? Auto copy feature must be active, so you should put show boot auto copy. Auto copy feature is enabled, right? And fourth, no auto copy to standby supervisor should be in progress, right? So you should see show boot auto copy list, so no file currently being auto copied while supervisor switch over, right? Once you are planning to do, no auto copy should be from primary to standby should be done. It should be done automatically via synchronization method. Once it is done, then you should and while you are doing the supervisor switchover, there should no currently file being auto copied. That process should not be started, right? At that point of time, your primary supervisor or active supervisor should not transfer any file to the secondary supervisor. At that point of time, you have to do the supervisor switchover. So these are the four methods you have to follow while preparing a switchover. And the main thing is it should be in HA standby state. Read it.